Okay, so I will be covering two topics. One is related to Turbonomics and one is related to Watson AI Ops. So hello everyone, a very good afternoon. My name is Bipin Chandra Srivatsava, and first I will take you through this AI-powered application resource management software that is Turbonomics. So here's the agenda I have. We'll start with a few limitations about the way we used to manage computer resources like CPU, memory, network, etc. Right? That is during pre-cloud era, and then we'll talk few things about how we do it during cloud era, and then we'll touch base on the complexity of the modern applications and the challenges they brings in. Then we'll give a brief introduction on Turbonomics, what it does and how it does. Then we'll take you through a demo of Turbonomic. We'll also talk a little bit about Watson AI Ops. So during pre-cloud era, applications were hosted on host systems, right, or VMs, and we provision resources upfront based on some kind of forecast which our developers, our product team suggest, right? And most of the time, we over provision these resources, and there was no concept of elasticity, and we manually add or remove the resources as and when something goes wrong, right? But during cloud era, we provision resources only when we actually need them. The concept of elasticity was brought in, but it leads to its own problem, right? When the applications and its architecture become complex, it becomes hard to decide uh, which microservices needs how much capacity during production. I mean, in real time, right? Just think of hundreds of thousands of microservices running in as many as that many containers in an enterprise. This again is still a reactive approach to decide on the capacity, either after the issue happens or just before it's going to happen, right? Based on some threshold. So these are some of these are some of the modern applications challenges. It's all about, see, modern application is all about better and continuous performance we have, right? But it also brings its own complexity. You see here earlier the applications were involved on VMs, and there were different teams, dedicated teams. You had like IT engineer, network team, DB team, and then you have dedicated tools to resolve this problem. But in the modern applications, it's all hundreds of containers are involved, and the release are happening in real time, right? It brings in on its own complexity to be solved, right? And that's where this Turbonomic comes in. It watches everything in real time, makes decision and take decisions in real time. So the application always have the resources they need. These actions, so whatever actions it suggests, it can be taken without human interventions as well, right? So this is how the Turbonomics supply chain model looks like. It has a list of your applications, and these are the different entities listed. I will show in the demo here. The image is not proper as such. And then you have different components. These are different targets associated with your supply chain. Like for application management, you have Instana or App Dynamics, right? And there are some other performance monitoring systems like infrastructure, compute, network, storage. So all these can be monitored through Turbonomic. Here, if you see this, this is the supply chain, and the first four components is business application, transaction, service application component. These form your application, but this application runs on some host, right? Those require CPU, memory, network, and all. So that
Sonia, uh,
sorry,
uh,
any question? Ganeshan, I think you need to be on mute. Yeah, thank you. So, and these are the things. These are the entities uh, which provides the resources needed for your application, right? That's why it's called as ARM tool. And so this, the application, it provides like how Neha and Chinmay explain on the Instana side, right? So it provide the congestion, where the congestion is. And similarly, on the ARM side, these resources, it provides what action can be taken on these resources when it monitors it if something goes wrong, or much before something goes wrong, it provides those details, right? And when there's an issue in the application, a blame game starts, right? That the issue is on the application side or the issue is on the hardware side. But you look at this image and you see all the red points. Those are the pain points, and those are the point where you have to look into. It then suggests some actions to be taken. You see, these are some actions Turbonomics has suggested you, like resourcing actions or application for application components, for virtual machines, like resize your VMs, right? And the physical host, some suggestion it provides, and similarly on the storage data stores. So these are some of the actions what Turbonomics provides based on their own ML programming, right? This is another chart where you see exists. So what this chart explains is this is your existing uh, capacity monitoring visibility, right? CPU, memory, network threshold, latency, all things is provided. This is your current system. And whatever the actions it has suggested or it has recommended, if you take those actions, this is how your system will look like post that. So this is one chart it provides based on its own um, analysis. Then it also provides that if you want to purchase, let's say, more reserved instances, or let's say you want to, it suggests to purchase more VMs, right? So it provides some those kind of suggestions also, and it provides how much investments you may need, and then it also provides how much potential savings you can make per month. So these kind of details also it provides. These are some of the targets as of today. Turbonomics supports. Okay, so I'll quickly move to the demo. Yeah, so this is how the Turbonomics looks like. Here, if you see, this is the supply chain model they have, and it lists down all the applications, business transaction services, right? And these are the containers details. If you click on any of them, it will take you there on that specific uh, entity, right? And so this application view, it provides all the health of all the application, not only just one application but all the application. It provides that detail, right? It also have on-prem means whatever entities or resources are installed on your on-prem, it provides that kind of environment details. Then on the cloud side also, it provides the complete detail. On the cloud, it provides many more things, like I just explained what are the investments you need. Let's say you want to purchase new reserved instance, and it also tells you how much money you will be saving if you take those actions, right? And these are the reserved instances coverage it provides, and these are some of the current utilization, and build cost. Yeah, these are the things it provides. And if I so if you click if you so Chinmay showed this RoboShop application, which is also integrated in Turbonomics here for the demo purpose. And here, if I click on this business application, it lists down all the like response time, transactions. This is transaction per second, right? This is network latency and throughput. So these are some of the default monitoring visibility metrics which Instana provides, right? And based on those metrics itself, it has some system default policies for each of the business for each of these entities. Like for business application, it has some constraints, and based on these constraints only, if it doesn't matches the criteria, some of the actions are suggested. Like actions would be like replace your VM with some other provider VM message, right? And then you have business transactions. It also has its own policies. then service, then container, right? And the VM, if I go to VM, it has multiple list of policies. So these policies are there, and these policies you can modify also. These are the system default policies, which comes by default by Turbonomics, right? Uh, then moving to the other components, this is search, which drills down each and individual component in what Turbonomics provides, right? You can always go and uh, drill down. Then this is the plan page. You can use plan page to run a simulation. It's like what will happen to your environment if you remove or add any resource, like if you want to remove any VM or you want to add any VM. So this is a simulation, right? What it does, it creates a snapshot of your current environment. It then modifies this snapshot as per your requirement, right? And then runs the plan. So before actually executing the plan on the resources on your environment upfront, you can have that simulated environment itself, and then you can dig and see how it will behave, right? So these are the predefined some plans they have for public cloud, for container, for on-prem private cloud. So these are some templates they have already created. You can make use of them to create your plan. Similarly, you have this work placement page. You can set up reservations to save resources for your workload, for your future need, right? So it's like in future you may need that this many VMs or this many CPU or this many memory. So you can just create that workload placement, the reservation for those kind of resources. And Turbonomics uses its intelligent workload management to calculate optimal placement for these. So what it does is the whatever the current workload you have, based on that it decides whether it will be able to reserve whatever you want, right? Those kind of resources. And here also it has some of the predefined resources which you can just click and ask that you may need this in future, and that's how Turbonomic will try to reserve them if it has sufficient that capacity. Now, dashboard, it is mainly created to view a different kind of environment based on a specific need to look at the health of your environment, like performance health, workload improvements, right? And different types of actions which are already performed, and whatever the risks which you have avoided, or any kind of costs which you have saved. So those kind of details it provides. And if you click on new dashboard, it will add these widgets. If you see that there are multiple such widgets, like potential saving or investment, so you can create your own dashboard, which will be helpful for you to make any business decisions as such. Okay. Coming to the settings, I'll not go much deep. Its groups is like a collection of resources, policies I already explained. These are some business rules, which Turbonomics makes use of it to help to for resource allocation. Templates is again for resource allocations only. It's like a predefined template. Let's say you want to introduce a new VM, so you will have a predefined template which will have predefined CPU, predefined memory for that VM, right? So you can have those billing costs, user management. So target configuration is one important aspect here. This has it's a service which helps Turbo to connect to your own environment, and then it monitors that environment, and then it can execute any actions. Like for APM, you see Instana is there, Dynatrace is there. These are APM tools. Then cloud native, you have Kubernetes. You can connect to any Kubernetes cluster from here. For this public cloud, you can connect to your AWS environment, Azure, right? You can connect to all these. So that was very quick overview on the Turbonomics. Any questions? If not, I will move to Watson AIOps. I already hit 4 o'clock, so we'll run a little faster. So Watson AIOps, So here the goal is to simplify management. Okay, so management of your computer resources, right? So ultimate desire for your any applications running is like to have a desired performance, and more importantly to resolve any issues faster and in proactive manner. Right? That's where this Watson AI Ops comes in. So we'll talk a little bit on the without AI ops. So without AI ops, how things happen today is MTTR is nothing but mean time to resolve. It's like how much time it takes when the issue has been detected and finally the issue has been resolved. So this is the time it takes, right? So time from the start of incident to corrected in production. So as of today, if you're not using AI ops, it's the time taken is little large, and it also involves human intervention, and then it also involves human expertise, right? It takes more time basically to resolve. But with AI ops, so things becomes little faster, right? So if you see here, the time taken to detect or time taken to acknowledge and time taken to identify, it drastically decreases, right? And that's how this time is saved, because things are not happening at the human speed, but they are happening at the computer speed. And here it's more productive, right? Not you are not taking action after the issues happen, and it's a little faster and much before actual the incident has occurred. So I'll explain how it happens. So what it does is it collects information from multiple data sources, like Instana is one such data source. Logs, metrics, events, there are some topology configuration happened, right? uh, and the application information as the monitoring metrics, like how Instana provides. And then it takes all this information and applies some machine learning on that and does some processing to give a detailed visibility into environment, which was not possible before, right? And then it predicts where you can have the failure. It's not that you have already have the failure, it predicts where you are going to have the failure, and then it facilitates the problems resolution, right? So this is a very high level architecture. Again, I will not go into deep into this. And so if you see here, these are the different data sources, and Instana is one such data source here. We have log, events, alerts, incident, and then the resource metrics related. So these all are fed into this Watson AI Ops. And so it has 5 major components: AI manager, event manager, metric manager, topology, and application discovery. And all this, what it does, it builds an AI model like for log. So these are AI models which are used for the processing, right? All the ML and processing happens into these layers. And finally, it provides you a detailed visibility, and based on that, then you can uh, predict failure. Any failure are happening, right? Watson AI predicts these things, and any problem resolutions, if it has, it provides those as well. There are two ways to resolve issues, right? If I will not go again in much deep into this, but just just to explain, so there are two ways to resolve any issues, right? If the same issue has already happened, right, earlier, and so Watson, what it does, it digs into its own repository, and then it find out what potential solutions it can be, and then it suggests these solutions, and then you take one of those solutions and resolve the issues, right? So that's the easy one. But most of the time we don't come across such kind of issues. So always there's critical issues, or 7 issues are basically it's like undiscovered problem, right? It's a totally new issue. uh, so Watson make use of the data, right? As I said, there are multiple source of this data it has collected, and be it structured, unstructured, semi-structured, or like it's coming from some application observability data, some monitoring tools as such, right? It collects from all these sources, and based on this data, and it does some processing, and based on some ML, and so it's machine learning programming. It understands what is the normal behavior, So if I go here, so if you see here, this was the traditional way of putting the threshold, right? You put some upper limit. In the upper limit, you get very less number of alerts. But if you put the threshold very less, you start getting a lot number of alerts. But when using Watson AI Ops, what it does, it makes use of machine learning, and it understands what is the normal behavior. It doesn't go fall to this static threshold. It creates its own threshold dynamically based on the workload, based on n number of uh, sources, data it's collecting. It predicts that at that point of time, this is the threshold, and at that kind of model it creates, and and if it hits outside that threshold, then it triggers alerts with complete detail of the issue, and also provide resolution, any possible resolution it provides. So that's all I have, right? There's a quick overview of Turbonomic and Watson AI Ops. Any question?
Bipin, Chinmay, and Nega, this is a very good, very descriptive session, and thanks for that. And I have a couple of questions. How the Shastra has got a cluster right now with the Power 9 as well as the other platform too. How they can get these softwares? Like, is it free for academia? Because they do have academic access, and they got a lot of softwares from IBM Power related components.
Yeah, so I think Instana does have, I think Neha has provided some trial version, right? You can download it and install some agent and do it. Turbonomics, I need to check. I don't have that thing, but I think Neha has provided that link as well for Instana to try out.
Well, very good. Because the Shastra is our, the customer, like, power customer for last 10 years.
Okay.
So they have now Power 9, and they are actually planning to buy more Power 9 systems and
Okay.
Power 10 also. So it's a kind of, like a role they are playing, one of the key power customers in India too. So anyway, if you could help, if your team could help, Rajesh Pal could help, that would be nice. And
Yes.
we can also, make them as a kind of a center of excellence for this AI ops, and we can, deliver this kind of, talks to other universities too with their help. So they got nearly 12,000 plus students, who could use these kind of features. And just want to tell you that. And even TCS is one of their Tata companies, one of their key partners, big industry partner actually. And even this workshop is funded by them. So
Okay.
just want to tell you that, like kind of a heads up, a great
Sure,
opportunity to
Ganesh.
work
I
with
think
them.
we'll love to help them by any means. Yeah. So about this, I think Instana, I already told you it's there. Turbonomics, I'll get it back to you. Okay. And definitely we would love
Yeah,
to have similar sessions for other universities as well.
sure. That is very good. Thank you very much, all three, Nega, Chinmay, and Bipin. Thank
Thank
you
you.
for a wonderful talk.
Thank you.
Thank you.
Thank you,
Any
Ganesh.
any any questions from the audience? Vinay, do you want to just check with the audience there? Online audience, if you have any questions, please go ahead and post.
So, any queries for Bipin, Chinmay, and Neha from your side? Sir, hope there are no queries from our side. So you can.
Okay. Even if you have any questions or any anything you want to ask or discuss, please do share it with us. Yeah, that's what I am. We are going to talk about it. Kavita asked about, if you want to make use of these tools, how to proceed. That's where, I'm going to set a note on that as a follow up to this.
Yeah.
Kavita, thank you.
And I'm posting my email ID just in case people have any questions, they can reach out to me.
Oh, thank you. Thank you very much, Bipin.
Yeah.
Okay, thank you very much. And yeah, team, give the Bipin, Nega, and Chinmay, round of applause. That will be nice. Okay,
Thank you all. Thank you.
Thank you very much. And I think, yeah, we are almost, yeah, close to the end of our session. I just want to give a summary note so that you all can take home and, and start using the cluster, whatever we have at Shastra. And, this is one of the best cluster, I would say, in India too, with, the multiple architecture and, the multiple softwares, installed on the system. So, last 3 days, started with Monday, and now we are actually close to the end of the workshop. We covered, three important scenarios. I would say solution development, not the scenarios, solution development, where uh, we started with Peter Hofsty, Dr. Peter Hofsty, who has got like 100 plus, published patents. And and he has been, he basically talked about open power cores. What does it mean? Basically, one can, go and develop their own SoC. I'm connecting the dots here. He talked about, the open CAPI accelerator and open power cores, where Abhishek this afternoon talked about how one can develop SoC, silicon on a chip, using those cores. So we do have a kind of, a platform, where you can, go and, start working on, developing a code, developing our own processor, designing and developing our own processor. Even we have ways to fabricate the processor and build a system. These are the things, we have been, communicating worldwide, through our open power foundation. And that's where, like, I'm also part of that. And I'm the leader for, the academia worldwide, for the open power foundation. So the Peter Hofsty's
to augment Ganesh, Shastra is an open power member.
oh, thank you, Professor Sriram, for connecting the dots here. Yeah, you have been member for last several years. We know that, like, we started that thing in 2015, open power member, and this is like nearly sixth year. And one can develop, design a core, and develop a system also with that. So many things, from the silicon to the application we can do. So one part of the workshop, like, developing a core, and the other part is high performance computing. Dr. Samir Shande, who is the exascale software leader worldwide, who presented about the E4S, which contains hundreds of libraries and tools for exascale platform. So all those platform tools and libraries be installed already in Shastra cluster, which includes MPI, Tau, and so many, the profiling tool, Intel MPI, and everything, and also some of the open source packages include a scheduler and Ganglia kind of monitoring tool and all. So go take a look at it. We are going to share the package, whatever we presented. Go take a look at it, and you can start working on the cluster immediately. And also we covered, one of the important thing is spectrum scale, and it's actually implemented in many high performance computing and large scale storage environments. So that's basically nothing but it's a file system used to distribute and manage data across multiple servers. What it's meaning of data across multiple servers. So that means what? Actually, basically, this is also installed in Shastra cluster, and you can use that GPFS file system and store your data. So that's another advantage you have right now. You can learn about even the file system and features and all the stuff. We do have good material which we are going to share it with you all. And we covered some application which includes OpenFOAM, and it's a development of customized numerical solvers and pre-post processing utilities for the solution of continuum mechanics problems, most prominently including computational fluid dynamics CFD tool. So a lot of automobile industry as well as mechanical industries and aerodynamics industries use this tool for so a lot of simulations. So we do have some industry experts who can guide more on this too, and we install this OpenFOAM on all your cluster systems on a Shastra cluster. Starting from today, you can start using it also. We have a kind of a guide also, which we are going to send it as soon as possible. And the Dr. Panda from Ohio State University explained about the middleware tools, especially the MER pitch 2, which can run across thousands of systems, and also Xscale AI for distributed deep learning. This is also installed as part of Shastra cluster. It basically serves, multi-purpose like HPC as well as, the deep learning, machine learning kind of exercises. So you can start exploring that also. And some fundamentals also we taught about machine learning, distributed deep learning, and the use cases. I hope you remember the Florin talk. He mentioned about several use cases across the industries, from the banking to the the healthcare and manufacturing and aerospace and many other industries. And there are a lot of use cases we do have, and some of them we showcased also. Like one of them is retinopathy, diabetic retinopathy, and the other one is the COVID-19 use cases. And certainly there are a lot of use cases you guys can develop and start using it too, with our the V100 GPUs running on Power9 system, AC922 system, accelerated computer, and also A100 on our x86 system. So all put together, you can run many deep learning and machine learning exercises and publish papers, and even HPC related, the MPI programming and publish paper. And today, as part of today's talk also, I hope you remember about this enterprise AI, where database also can play a big role here. Without using CUDA, as well as Dr. Shivakumar mentioned about, without using CUDA, with the DB2 you can do a lot of the machine learning, deep learning exercises. So take a look at it, and go, even the enterprise AI, whatever the use case we Shiva presented, it's going to be deployed in Shastra cluster. Start using that also. We will give the document as part of that. And then one of my the students, as well as the technical leader, students in IIT Jodhpur, and a technical leader in the industry, talked about MER pitch programming, which included a demo in Shastra cluster, how to compile and deploy the MER pitch 2 application. Whatever Dr. Panda discussed yesterday, he basically deployed it in your cluster and running special OSU benchmarks. These benchmarks are very important for top 500 kind of the supercomputer competition and all. So take a look at it. We are going to send you the the documentation on that too. So we talked about open power course, open CAPI, HPC, the exascale, and distributed deep learning. And also one important thing I forgot to mention in between, that the augmax, the data is very important for any kind of solution development. And we discussed about augmax tool, which helps to visualize the features of augmented images fed into the network during training. So this is a recently released research tool, recently in the sense I'm talking about October 2021. And also this has been demoed in a supercomputing conference which was held last month in St. Louis in US. And that tool has got a lot of potential. People can get some kind of patents and publications and all using that. Take a look at it. We do have installed. We have installed in Shastra cluster, which you can take a look at it too. And last not the least, the Watson AI Ops team talked about the features and the introduction to observability, power systems observability, AI powered application resource management, and Watson AI architecture. So we will help you out on installing some of the AI Ops tools too, and the Watson related tools too shortly. And with this, I'd like to conclude the session. And I'd like to invite Professor Sriram to say a few words. Sriram,
Yeah.
please go ahead.
Thank you, Ganesh. Thank you very much for arranging such a wonderful workshop and with hands-on. And I thank all the speakers and the team IBM, the Open Power team, as well as the participants who have been actively engaged in the workshop for the past 3 days. I really appreciate the efforts of the presenters and the speakers who have really worked and have shared their years of experience in the allotted time. and it was really a thankful. It was really a useful session for the past 3 days, and thank you very much. And I believe that the questions that the participants had raised have already been answered. And this is not a conclusion. This is only a start now. We will have series of such workshops that will enlighten the participants of the workshop on how to effectively use the deployed HPC and usage of the plethora of applications that have been installed in the HPC. And thank you one and all. Thank you very much for your patient listening. And I think that we can say bye now, and we'll meet again in the next workshop. Thank you very much. Namaste.
Yeah, thank you all. Thank you. Thank you for all the organizers too. Thank you very much. Thank you. It's a very good first hybrid workshop which we tried in Shastra. Thank you.
Thank you. Thank you.
Thank you all. I'm closing the session. Thank you.